folks. Last time I checked in with you guys, you were talking about solubility and how to determine whether something is soluble or not. Well, our focus today is going to be looking at that in an equation form. So if you remember, we've talked about chemical reactions before and how to predict products, something along those lines. Well, today, our focus is going to be determining whether the products are going to be aqueous in solution, that is, being dissolved in water, or if those are going to form what's known as a precipitate, which means that it forms a solid due to the fact that whatever reaction is taking place, the compound that is produced would be insoluble. You'll see what I mean when we dive into this here in just a moment. So let's talk a little bit about our learning targets for today. Hopefully by the end of this video, you'll be able to understand how precipitates form in chemical reactions. And then hopefully you'll also be able to write out full and net ionic equations of chemical reactions to determine what precipitates in a chemical reaction. We have quite a few key vocabulary terms for this video. That includes full ionic equation, net ionic equation, and spectator ions. Now, when I say a lot, we mean three. Three is not considered a lot. Three would be considered few. So in light of that, let's make few the word of the video for today. So as we've talked about before, chemical reactions in solution are very similar to other chemical reactions. As you can see on the right, we've written a balanced chemical equation that's very similar to what you've looked at before. That is known as a double displacement reaction. If you're given two reactants, just like what you're given on the right-hand side, you're going to want to go through and predict the products as normal. You've got ammonium sulfide reacts with cadmium 2 nitrate. It's a double displacement reaction, so all we do here is we switch out the anions. So we switch out the sulfide ion with the nitrate ion, and we get ammonium nitrate and cadmium 2 sulfide. The next thing we do is we look at the solubility chart to determine whether they are soluble or insoluble in water. So if we look at NH4S on the solubility chart, that tells us that it is aqueous in solution, so it will dissolve, it will break apart, it will dissociate in water. Cadmium nitrate does the same thing. All nitrates are soluble. If we look at the products that are produced, one of the products is aqueous, ammonium nitrate, dissociates completely in solution. But cadmium 2 sulfide does not, so we label that an S. So it's just like I said, it's the same process that we've done before when we've gone through and looked at chemical equations, go through and balance them, all of the stuff that we have talked about previously. But the difference here is that we are adding states of matter by utilizing the solubility rules that are discussed in the previous video. So when we look at total ionic equations, they show all of the ions with charges that are dissociated in solution. Remember that solids do not break apart. So we've actually practiced this quite a bit when writing dissociation equations. You know that if it's aqueous, it will dissociate into its individual ions. If it is insoluble, it does not dissociate and stays together. So if I look at the previous equation, I've got ammonium sulfide reacting with cadmium 2 nitrate again. The first two reactants are aqueous. So when we write our ionic equation, we write them in their ions, ionic ions. You get the idea. So we write those out. So NH4 plus. Remember, keep in mind that if there are multiple of those ions, we don't keep them as subscripts. We move that to a coefficient because remember, they break down into the individual ions. NH4 2S will break down into two NH4 ions and one S ion. Like I said, just what we've talked about previously. You do the same thing for cadmium and nitrate. You can see we've got that there. We have our ammonium nitrate together, but we also have our cadmium sulfide. Remember, solids do not break apart in solution. So our CDS stays together. Now, what I look at next is I go through and I write the net ionic equation. Net ionic equations show only the compounds that undergo a change in the chemical reaction. You want to look for changes in state. So, for example, if something goes from aqueous on one side of the equation to solid on the other side of the equation, you would want to keep those as those change in state. Ones that do not participate are known as spectator ions. These are canceled from the reaction to produce what's called the net ionic equation. So as you see, NH4 is on the left, 2NH4 plus aqueous is on the left side of the arrow, and it's the same on the right side of the arrow. So those cancel. Same with your nitrate ions on both sides, but remember your sulfide and your cadmium change states of matter. So those are the ones that participate in the chemical reaction. So as a result, your net ionic equation is bolded down below where we have Cd plus 2, which is aqueous. sulfide is -2 aqueous, and that forms cadmium 2 sulfide in a solid form. Okay. So again, the whole concept here is to break down everything into your ions. Unless it's insoluble, then you leave it as a solid. You cancel everything on both sides that is the same, and then whatever's left over is your net ionic equation. That is what actually underwent the chemical reaction that is discussed. Let's take a look at a practice problem and go through it together. So the question is very straightforward. It states to write out the net ionic equation for the reaction of zinc nitrate and ammonium sulfide. So our first steps are to write our reactants, predict our products, balance, and make our chemical equation. So let's go ahead and start off with writing our chemicals. So zinc, Zn, nitrate, NO3. So zinc, remember, is a +2. NO3 is -1. So this is ZnNO3, 2. Reacts with ammonium sulfide. Ammonium is NH4. Sulfide is S. You have a +1 and a -2. So this is NH4, 2S. Okay. And now we need to predict the products of that. So remember, we just switch out whichever one, we switch out our anion. So we're going to switch NO3 with S. So what we're going to get is ZnS plus NH4 NO3. There we go. And again, we look at our charges. So we got +2, -2. We've got a +1 and a -1. So everything cancels out. Before we move on to the next part, we need to balance our equation. And in order to do so, we write a 2 where you see NH4NO3. That balances our equation. All right. So now we go through and we need to write the net ionic equation. So now we go forward, we need to write our total ionic equation and then our net ionic equation. So let's start off with our total ionic equation. So we're going to start with the zinc ion, it's aqueous, plus we have 2 NO3 ions. Those are also aqueous. We have 2 NH4 ions. Those are also aqueous. We have a sulfide ion. Again, aqueous. We produce zinc sulfide. Remember, that is a solid, so that stays together. So ZnS, that's a solid, plus, and again, we've got 2 NH4. That's aqueous. And 2 NO3s. Again, aqueous. Okay? So now that we've written our total ionic equation, we need to write our net ionic equation. It's pretty straightforward to do here. We just cancel everything that's the same on both sides. So I've got 2 NO3s, so I'm going to mark those out. I'll pick a different color for this. So 2 NO3s on each side, those cancel. 2 NH4s on both sides, those cancel. So if I take a look, what I'm going to be left with is Zn plus my sulfide ion yields zinc sulfide as a solid. And there you go. Okay. So take it, follow it. What's that? Take it, follow it one step at a time. You should have no problems being able to work through this. Okay. The tricky part to remember, though, make sure you go through, follow all the steps, and balance the equation before you move on to anything else. Make sure everything's all good in this first equation up here at the top. Okay. That's going to help you moving forward. Also, make sure to remember that your subscripts change into coefficients unless it's a polyatomic ion. Okay, even if you have coefficients at the top, for example, that 2 for NH4NO3, that still gives you 2 NH4s and 2 NO3s. So be careful as you go through and balance this, otherwise you're going to end up with some weird, funky looking ions that aren't where they're supposed to be. So in order to make a very long story short, net ionic equations are written based on what is able to dissolve in solution and what changes during the course of a chemical reaction. So you need to use the solubility chart in order to be able to solve those types of problems. Anything that is aqueous in solution is dissociated or broken down into its individual ions, while solids do not break down. And then you use this data and information to write your net ionic equation. All right. Hopefully we were able to reach our learning targets for today. This is the last video for the solutions unit, unless I decided to switch things around a little bit. We're going to finish up the year with acids and bases momentarily. So hope you guys have a great day. We will talk to you later, and we will see you next time. JLand Bio signing out. Peace.